Welcome to this explainer. Imagine your corporate data is literally blocks of solid gold. You wouldn't just walk that gold down a busy public street to get it to the bank vault, right? No way. So today, we're going to learn how to safely route your on-premises traffic to Azure Storage by building a completely secure private tunnel. Think of this as a virtual whiteboard session. I've got my signature dark navy and red markers ready to go, and we're going to draw out this whole complex networking process step by step so it's crystal clear.
So here's the core problem we're tackling today. How exactly do you route that on-prem traffic to Azure Storage without ever touching the public internet? Because by default, when you spin up an Azure Storage account, it's sitting out there on a public endpoint. Sure, it requires authentication, but your sensitive data requests are still traveling along the busy public streets of the internet. And for most corporate workloads nowadays, that's just an absolutely unacceptable risk.
Okay, let's dive into this comparison. Over here on the left, sketched out in navy ink, we have our busy public street, representing public endpoints. Anyone can see your armored truck driving by, even if they can't easily break in. But on the right, highlighted in our bright red, we have the secure private tunnel. That's Azure Private Link. Now the armored truck is completely out of sight, moving directly from your local network straight into Azure.
To get this architecture built, we're following a 5-part blueprint today. First, the public street problem. Second, the private tunnel solution. Third, bridging the network gap. Fourth, solving the notoriously tricky DNS puzzle. And finally, validating your secure vault. Let's get right into it.
Starting off with part 1, the public street problem.
So relying on just authentication, a strong password or an access key, honestly isn't always enough. With public endpoints, your traffic is still traversing the public internet, which means you've got a potential attack surface. If your organization is handling highly confidential stuff, network-level isolation isn't just some nice-to-have feature. It's mandatory, and you just can't get true network isolation if your front door is left wide open to the internet.
Let's move on to part 2, the private tunnel solution.
The crucial point here is understanding what Azure Private Link actually does. It's essentially a secure connection that grabs an Azure platform as a service like Storage and brings it directly into your own virtual network. It literally assigns the service a private IP address from your local subnet. And because of that, your traffic never leaves the Microsoft backbone network. It never touches the public internet. It's just a direct, completely private tunnel straight to your vault.
And building this tunnel boils down to 4 fundamental steps. Step 1, establish the physical connection, so either a VPN or express route. Step 2, create the actual private endpoint inside Azure. Step 3, configure your DNS resolver so your machines know where the tunnel even is. And Step 4, disable public access to officially lock that front door. That's our overarching roadmap right there.
All right, this brings us to Step 3, bridging the network gap.
Before you can actually use the tunnel, you've got to physically connect your office to the Azure environment, and you generally have 2 ways to do this. First up is Azure Express Route. You can think of this as a dedicated private fiber optic highway built exclusively for your armored trucks. Super low latency, highly predictable performance. Or you can go with a site-to-site VPN. This is more like taking the public highway, but you're putting your truck inside an impenetrable, highly encrypted shell. It's a lot quicker to deploy, still very secure, but, you're subject to standard internet traffic conditions.
Now, what's really fascinating here is the sheer power of this single action. The moment you create that private endpoint, Azure essentially injects a network interface card directly into your VNet. So your massive cloud-scale storage account suddenly starts behaving like a local server sitting right next to you in the server rack. It'll just respond to a familiar private IP address like 10.0.1.5.
But hey, having a private tunnel is kind of useless if the public doors are still wide open, right? You absolutely must explicitly disable public access on the storage account. This stops all internet-based requests cold. It forces every single piece of traffic to travel exclusively through your new private IP, completely eliminating the public attack surface. You have effectively, officially, locked the bank vault from the outside world.
Next up is part 4, solving the DNS puzzle. We have our secure vault and our hidden tunnel. But now we face a new, notoriously complex challenge. How does your on-premises network actually find that hidden tunnel entrance? Because when an app in your local office asks for the storage account, its local DNS server is naturally going to try and resolve the standard public address. So we need to seamlessly intercept that request and hand it the new private IP instead, and we have to do it without breaking anything else in your network.
Enter the Azure DNS Private Resolver.
Back in the day, engineers actually had to build and maintain custom virtual machines just to forward DNS requests back and forth. It was a total management headache. But the Private Resolver is a fully managed service. Think of it as this automated, highly intelligent GPS system that just seamlessly routes all those DNS queries between your on-prem network and your Azure private zones.
Let's methodically trace the path of a request here, drawing this out in our red ink. First, a local computer asks your on-premises DNS server for the storage account. We configure what's called a conditional forwarder on that server, basically telling it, hey, send this specific request over the express route or VPN directly to Azure. Next, the Azure DNS Private Resolver's inbound endpoint intercepts it. And finally, it checks the Azure Private DNS zone and successfully returns our private IP address, say, that 10.0.1.5 we talked about. And this brilliantly illustrates the exact namespace you need to configure for this to work with blob storage. Your private DNS zone literally has to be named privatelink.blob.core.windows.net. Azure heavily relies on this very specific naming convention to correctly map the original public name to your brand new private endpoint IP address behind the scenes.
Finally, we arrive at part 5, validating your secure vault.
You've built the whole architecture, but honestly, we never assume a vault is secure without testing the locks first. So here is your practical checklist. Number 1, check the Azure portal and make sure the private endpoint connection state actually says approved. Number 2, open up a command prompt on an on-prem machine and run an NS lookup against your storage account URL. It absolutely must return your private IP, not a public one. And number 3, we're going to use Azure's advanced diagnostics.
I like to think of Azure Network Watcher as the ultimate security camera system for our private tunnel. By firing up its connection monitor feature, you can actually track the live traffic flowing from your on-prem client directly to the storage account. This is how you definitively prove to your security and compliance officers that traffic is routing exclusively through the private IP, ensuring absolute zero data leakage to public endpoints.
As cloud architecture expert Nawaz Dandala put it, private endpoints are the gold standard for securing Azure Storage connectivity. Yes, it requires methodically setting up the network links and really carefully configuring that DNS puzzle we just looked at, but the payoff? It's absolute, verifiable network isolation for your most sensitive corporate data. You have completely bypassed the public streets.
By following these structured steps, you've essentially transformed a public-facing cloud storage account into a strictly controlled, highly secure extension of your very own corporate network. So, with your vault fully secured and the private tunnels safely hidden from the outside world, what sensitive workload are you going to migrate to Azure next? Thanks for joining me on the whiteboard for this explainer today. Keep learning and keep building securely.